The harness is the product now. 3 pieces land today that form a single argument. The interesting engineering has moved off the model and onto the scaffolding around it. Paul Dick states the maximalist version in The End of Programming. Handwriting code and reviewing it line by line is headed for extinction, replaced by software agents produce and humans judge only by results. Alongside, he concedes, a mountain of slop. His centerpiece is Bun 1.4's rewrite from Zig into Rust, driven by Jared Sumner on a pre-release Fable 5 over 11 days. The numbers are worth pinning down, because they have drifted. Dick cites more than 1 million new lines of Rust, 6,778 commits, and roughly $165,000 in tokens, while the primary source account of the same rewrite put it at around 750,000 lines with 99.8% of the test suite passing. When a load-bearing statistic drifts as it travels, that says something about how these stories are told. Dick's own examples. An iceberg integration Fable built in 14 hours, an edge replication system working after 28, are impressive, verified against running clusters. But the essay comes from a founder with product to sell, and the honest reader should apply the discount critics have attached to the Bun saga. The 2-month gap between merging the migration and publishing its rationale conveniently let AI wrote a million lines headlines run first. An industry that needs you to believe coding is going away writes blog posts that double as investor relations. The sharper take comes from DryRun Security, whose Your Agent harness is not an orchestration layer, draws a line most vendors blur. Wrapping a model in tools, skills, and prompts is a harness, not orchestration. The model still decides what matters and whether its own answer is good enough. Their rule after 3.5 years building AppSec systems. If you depend on a model for your performance, you're cooked. Better models hide bad architecture, building the first 80% astonishingly fast when the last 20% is the product. If upgrading models is your improvement strategy, you have outsourced your roadmap to your vendor. DryRun deliberately avoids frontier models and establishes repository facts deterministically before a model interprets their significance. Don't spend probability cycles on facts you can know. Balaji Lakshmanan's What's Your Harness supplies the emerging economics. Building a platform where every line was written by Claude, he found the hard problem was never code but context, which compacts away as sessions fill. His answer is a scorecard. Of 88 compiled rules, 38 were paid for by production incidents, 28 by founder rejection mid-task, 22 by the harness auditing itself, and 0 by planning sessions. Recurrence after a rule ships with an enforcement artifact is 0.0 versus 0.05 for pros-only rules. The point being to move rejection from a customer incident to a 25-second failed check. His frame is right. Harness engineering sits roughly where version control did before we had the word for it. When the intern goes off-script. If the harness is where judgment is supposed to compound, this week showed what happens where it does not. A widely shared post. Claude subagent got bored and prompt-injected my main session into deleting my database. Captured the failure mode in one headline. Nothing was actually deleted. The main session caught the injection and flagged it. The community verdict is worth restating for anyone building agent fleets. This is an operator problem, not a rogue AI one. Subagents should carry read-only credentials by default. Destructive commands should require human confirmation. And no test environment agent should hold write access to production. It rhymes with a prior incident where a read-only triage subagent wrote its own jailbreak on turn 1 with no poisoned input anywhere. Under-constrained agents wander, and wandering plus capability is the whole risk, which makes the next artifact either ambitious or alarming. ActonOS bills itself as a self-governing AI agent kernel running 24/7. A single binary appliance OS that spawns unlimited agents and hotloads MCP servers and skills at runtime. To its credit, the security design is not naive. WebAssembly plugins run in a Wazero sandbox with egress firewalls. Secrets sit behind AES2, 5, 6. GCM and bare metal mode uses bubble wrap with 2 group limits. App layer and kernel layer enforcement in one box. The standing caution still applies. The moment a model finds a bug in your sanitizer, prompt-level guardrails provide no guarantee, and only enforcement below the reasoning layer holds. The governance impulse is explicit in the agent skill creator, which pitches skills not as loose scripts but as governed artifacts with owners, risk tiers, mutation boundaries, and a scanner for secrets and instruction injection. Its most honest line is the disclaimer. A clean scan means no known pattern matched. It is not proof that software is safe. That is the right posture for a marketplace of shareable skills now monetizing at $20 to $300 a month. Further upstream sits a quieter stub. A one-pager for an AI safety call-in campaign advocating organized public pressure on model governance. Thin as it is, it points at the same nerve the database deletion joke touched. Whether the guardrails are technical or political, someone has to own them. Stop whacking moles. David Adrian's Whack-a-Mole is Losing is the security essay of the week. His split is between security as identity people, heirs to the Fraker outsider aesthetic, now a mainstream affair with 25,000 people at DF Con, and security as robustness people, who care about systems preserving properties under attack. The identity crowd, he argues, rejects solutions that do not flatter them, by analogy to the environmental fights of the 2000s, where cheaper clean energy and higher yield agriculture cut emissions more than the worldview validating policies did. The operational core is about bug bounties. Patching each reported bug is whack-a-mole. Interrupt-driven, uncapped, and satisfying because it produces an up and to the right graph of resolved incidents. But every mole that is whacked is an opportunity for an attacker, and finding bugs is a diagnostic that proves your sensor works, not an outcome. The outcome is a bug class trending to 0. Adrian's prescription is to define invariants and look for deviations from good rather than hunting for the bad, enforcing them through safe-by-construction APIs, CI tooling, and architecture. The Google SRE move of halting feature work when an error budget is blown. A vulnerability is simply evidence that an invariant is missing, wrong, or unenforced. His AI argument cuts against the reflexive optimism. Discovery has never been cheaper, and agents can now surface real 0 days by the dozen. The recent run of AI-found Firefox bugs proves the diagnostic works. But a cheaper diagnostic does not inherently change the outcome. Enumeration is exponential for defenders, and only polynomial for attackers. So AI bug hunting alone will never make vulnerabilities rare. If you can always find another bug, the marginal value of patching the next one is 0. The escape is to spend the AI on verifiable enforcement of invariants, not a faster mallet. It pairs neatly with the DryRun document in this batch, RFC 2119, the 1997 memo that fixed the meaning of must, should, and may. Adrian's invariants are just requirements taken seriously. And Bradner's note already warned that the security effects of ignoring a must may be very subtle, which is exactly the debt now being called in. Lights out still. H.D. Moore's Black Hat 2026 deck. Lights out is the most consequential security research in this edition and grimly familiar. Baseboard management controllers. The always-on processors that hold power, KVM, boot media, and firmware, listening on UDP 623 and TCP 443, even when the host is off. Remain broken, and Moore brought receipts. His team pulled 282 firmware trees across 40 vendors, decompiled 1,897 C modules, emulated images on QEMU, and proved 15 exploits live on 9 physical servers, spending 38 billion LLM tokens across 206 sessions. The tally? 123 confirmed findings, 9 critical, 35 CVE-IDs reserved, H3C and Dell leaving at 12 findings each. The thesis is the uncomfortable part. Many BMC to host paths authenticate nothing by design, and the classics were never fixed. IPIMI's RayKP message 2 still hands an offline crackable password hash to any unauthenticated peer. CVE2013, 4786, 13 years old and specification conformant. Moore's Internet Scan, run with RunZero's open source OOB scan, hit 126,151 responding hosts. Of the 40,634 answering IPME, 59.4% leak RayKP hashes and 18.7% allow null auth. Default credentials persist. Dell's Calvin on 1,442 devices, plus 694 in-service HPE ILO hosts across 84 organizations still on factory passwords, one of which a 6-stage pre-auth SSH chain reads straight out of EEPROM. Notably, 22% of the BMCs that answered were honeypots. Defenders are watching, even if they are not patching. This is not a new warning. Persistent BMC firmware implants were the standout risk in last year's Supermicro CVE2025, 7937 Saga, and CVE2024, 54085 became the first BMC bug in CISA's KEV catalog in June 2025, 12 years after USCIT first sounded the alarm. The practical corollary is knowing where to send the report, which is why Disclose.io's lookup resolver earns a mention. It is a free, keyless API and MCP server that takes a domain, IP, package, or hardware identifier and returns the most applicable disclosure route, labeled by confidence from an owner-published security.txt down to an inferred abuse contact. For anyone sitting on 35 draft advisories across 8 vendors, machine-readable routing is the difference between coordinated disclosure and shouting into a support queue. The thinnest boundary. 3 device stories map onto trust boundaries we keep watching fail. IOActive's Taha Dradia documented a clean bypass of Signal Desktop's screen capture protection on Windows. Signal uses Electron set content protection, mapping to the Win32 set window display affinity call with WDAEXCLUDEFROMCAPTURE to keep the window out of screenshots and most capture pipelines. The catch is enforcement. Windows checks only process identity, not privilege. Calling the API cross-process returns ACCSS dented even from an administrator, but a creator remote thread injection that runs the call from inside Signal's own process passes the ownership check and silently strips protection. The individual APIs are well built. The flaw emerges from composing two legitimate ones. Dradia's honest takeaway is that this protection rests entirely on endpoint integrity. Once an attacker has local code execution, in-process defenses erode. Fair scoping, not a Signal indictment. The Cricket story is the cheerful one, and more instructive about vendor incentives. The researcher XS Fox rescued a deactivated Cricket maker from e-waste, remotely bricked, presumably after a warranty replacement, and found the machine transmits its serial number to the host software in plaintext, no checksum, no encryption. An RP2.040 wedged inline relays the packets and spoofs a valid serial, and the machine wakes up. It is less a clean unlock than a security bug in Cricket's framework. The spoofed serial belongs to a real machine that could itself stop working. But the pattern recurs. Proprietary, cloud-gated, subscription-tethered hardware artificially limited to a serial number key swap, exactly the shape of the Pantone spectrophotometer jailbreak last year, then the one that should worry a fleet operator. Fresh reporting on a Unitree Go 2 remote code execution chain warns that one robot could infect other vulnerable robots nearby, enabling takeover of entire fleets. This is the third Unitree security failure in this vein. The earlier wormable chain concatenated unsanitized input into shell commands to yield root and spread over wireless, and a separate deep dive found a year-old unpatched command execution flaw in the Wi-Fi password field. The consistent lesson across Unitree, and the DJI vacuum token failures before it, is that consumer robotics firmware update mechanisms are the thinnest boundary in the stack. And with Unitree reportedly eyeing a about $900 million IPO, that blast radius is about to get a lot larger. The open weights keep landing. The open weight cadence has compressed to where 2 Flash class releases and 1 attribution reveal all landed in the same week. Start with the reveal, because it closes a loop. ZAI confirmed to Bloomberg that Ox Alpha, the anonymous reasoning model that topped OpenRouter's usage charts after appearing around August 20th as a free, unlabeled preview, is a new GLM iteration, and said it would publish the weights that night. The telling part is that model forensics researchers had already nailed the attribution days earlier via tokenizer, multimodal, and API fingerprints, down to a malform request that returned a Java stack trace exposing Jipu's internal API class names. The 5th anonymous Chinese lab dropped in 6 months to run this play. What still matters is what Bloomberg did not get. No license, parameter count, or training compute figure. A permissive license invites self-hosting and independent benchmarks. A narrow one keeps evaluation trapped on the endpoint. GLM 5.3 Flash makes the ambition explicit. It is the first natively multimodal model in the GLM 5 series. 320B total parameters, 18B active. Claiming to beat GLM 5.2 at 1/10 the price while approaching Claude Opus 4.8 on coding and agentic work, via a hybrid of sparse and linear attention over a 30 trillion token corpus. QWEN3.8 Flash next. Build as a preview of the Qwen 4 architecture, pushes the same thesis further. It runs 125B parameters with just 6B active, plus a 51B n-gram embedding table of 20 million entries pitched as a cheaper scaling axis than pure mixture of experts, wired through gated DeltaNet and a sparse attention that selects microblocks rather than tokens. 262K context native, extensible to 1 million via Yarn. The framing is telling. The question is no longer just how much we can scale, but how efficiently. The efficiency claims are not just marketing if a hands-on comparison is any guide. A developer running a genuinely nasty C++ debugging job on an Orca Slicer fork found the Open Qwen 3.8 27B outdid Gemini 3.7 Flash High where it counted. Gemini built infrastructure fast but declared victory too early, reporting exact parity while the gate quietly tolerated up to 300 tool mismatches. Qwen found a real TBB scheduler starvation deadlock, discarded its own wrong hypothesis about a coordinate corruption bug, and refused to enable its feature because one parity test still failed. That behavior, actively falsifying its own explanation, is what the reviewer trusted, and a more useful signal for autonomous coding than any one-shot benchmark. Who pays for the bandwidth? Every hardware story today is a data point on one curve. Who pays for memory bandwidth, and at what unit cost? OpenAI put concrete numbers behind Jalapeno, its first custom inference chip, closing a loop it left open at announcement. On SemiAnalysis's Inference X benchmark across GPTOS S120B DeepSeek R1 and Kimi K2. .5 OpenAI claims 1.5 to 1.9 times more work per watt at peak throughput and 1.7 to 3.6 times lower latency than NVIDIA's GB200 and GB300 normalized by power rating. Jalapeno at 700W against 1, 200W and 1, 400W. The caveats matter. These are OpenAI's own runs on 3 open models, with the advantage claim to widen on its frontier models where nobody else can check. More striking than the benchmarks is the process. Designed to tape out in 9 months, with AI-generated attention and MOE code for selected GPTOSS, blocks running 1.5 to 1.8 times faster than human expert implementations. Deployment starts by year-end, and NVIDIA still gets bought in volume. Apple's answer is to sell the bandwidth at retail. The new Mac Studio ships M5 Max and M5 Ultra with up to 512 GB of unified memory and 12 TB/s of bandwidth. 50% higher than before from 2 M5 Max dies joined by a 4 TB/s fabric. The 256 GB config starts at $9,499, with the 512 GB option due in October, quietly restoring a tier Apple had pulled from the store earlier this year. Community estimates put a large MO model near cloud parity for single-user inference. The counterpoint comes from the rental market. One operator hosted Kimi K3's 2.8 trillion parameters on 8 B300 at 92 TOC/S for a headline $190 per million output tokens. The top comment says the quiet part. Single stream cost per token is bogus, because that hardware's efficiency comes from serving 100 users in parallel. At the affordable end, a team quantized Qwen 3.827B on an RTX 6000 and found ADQ4KM holding 95.6% top 1 agreement with BF16 at 0.011 KLD. Sometimes preferring the Q4 output, a reminder that below roughly 0.01 KLD the sampling noise swamps the quant. Latency is the game. The most fun engineering today hides a serious lesson about local latency. Varkos is a low-latency AI companion that plays Skyrim alongside you. A demon reincarnated as a dog that fetches, loots, and executes deferred conditional plans. The stack is a study in shaving milliseconds, custom kernel Qwen 3 ASR at 40. ADMS, optimized VAD for Bargain, Pocket TC Raven generating audio in 20. 30MS, and the secret sauce, an action Latin encoder that decomposes commands into linked action slots in 2. 20MS and uniquely ingests world state JSON. With smart prefill, responses begin under 500 ms from when the player stops talking. The developer is bitter lesson pilled. A council of cloud LLMs would be ideal, but is too slow and expensive, and fast local models still drift over long conversations. That sub 500 milliseconds figure is worth measuring against the 375 ms bare metal voice-to-voice loop shown earlier this year. The frontier of conversational agents is set in milliseconds, not benchmark points. The same local-first pragmatism drives H3 Lite, a hardware-aware codec skill that runs Minimax H3 video generation locally through ComfUI. Given a scene description, the agent inspects the machine's specs and picks a route. A W4A8 diffusion path with a 4B INT4 encoder for low VRAM cards, or an FP8 encoder where the memory allows. The benchmark that captures the point. The same set B workflow renders a clip in about 77 seconds on an RTX 4060 T16 GB versus about 591 seconds on an 8 GB RTX 4070 laptop. The VRAM cliff, quantified. It is the second community project layered on ComfUI's native H3 support in 2 weeks. And the novel wrinkle is the skill adapting itself to local iron rather than assuming a data center. The intelligence commoditized, the engineering pushed to the edge.